Also, are you recording, Tim?
Yes. Yes. I think we're live.
Okay, let me check. Yep, we're live.
Okay. Well, hello everyone. Welcome to today's episode of Corecast. I am your host, Tim.
And I'm Mikey.
And this is Sile. Welcome, everybody, to a brand new, exciting episode of Quirkcast. Before we get started, if you haven't already, do join our Discord channel. And if you're watching on YouTube, we do this every Tuesday, 5 p.m. Pacific, 8 p.m. Eastern. Do ask us questions during the episode. Without further ado, let's get to it. So Tim and Mikey, this episode is interesting. I guess like I want to start off right at the bat. When people read this episode, they might think it might have something to do with the multiverse, or I'm just curious, like, how is this different than all the other stuff we've talked about? Like, because definitely there's certain things with our senses we can't perceive, and then when you go to quantum mechanics, you have all these different interpretations of universes you can't possibly interact with, but like all possibilities are happening. So I just want to kind of set the stage of like, how is this discussion different? I guess Tim, I'll point to you first.
Yeah. So the idea is that there might be dark stuff beyond just dark matter and dark energy, and this is not your multiverse, not your I don't know what you call it, fifth dimension. No, none of that. This is physical. This is real. Basically, we have evidence that dark matter and dark energy exists. We perceive its physical effects. Yeah. And now more and more, I think physicists have started to embrace the idea that, hey, look, dark matter and dark energy could just be the beginning. This could be the tip of the iceberg. There might be much more, there could be a lot of dark stuff in the universe, and dark matter and dark energy is just its most basic effects. So there might be a lot more that we don't know than we do, and that's sort of the idea.
Wait, I just wanted to clarify something just for the audience. Like, you don't mean that so if we look at the energy budget, people might know that, it's like 5% visible matter and then 25% what we call dark matter, and then the rest, 70% or whatever, what we call dark energy. You don't mean that there's stuff in addition to that, right?
Right? No. Yeah, I don't mean
Yeah.
that. I mean that
So
like
we say beyond dark matter. You said there might be stuff other than dark matter beyond dark matter. So I was like, yeah, just to clarify.
yeah. What I mean is that the effects that
Yeah.
that that are created by dark matter and dark energy, there might be a lot more possibility than we previously know. It's not just that, oh, there's just some substance floating there that is sitting there doing nothing. They might be doing a whole lot more because we don't see
See,
them.
yeah, like I feel like you're assuming that people think dark matter is boring. And for us who've worked on this and worked on theories of dark matter, that is always the assumption, right? That, oh, there's dark matter and it's probably just some boring stuff. Um, and I've always been a proponent of the fact that this is like kind of ridiculous, right? It's kind of ridiculous to think that this big part of the universe that we can't perceive is probably just like, I don't know, like just some dust, and we're the only interesting things going on in the universe. That seems like human hubris. It just smells like it.
Yeah, I guess, Mikey, could you give a lightning quick intro of what dark matter and dark energy is for any new incoming audience members? Just kind of set the stage and why is it called dark?
Yeah, so I mean, there's a long story history that we could do like a whole episode about, but since this episode is not about that, I'll just like skip to the front, the most recent I guess experiments, and say that like when we look out into the universe, we see like these days we have telescopes that can see we detect the light from distant stars, and that's usually what telescopes do, right? But thanks to Einstein, we have also a technique called gravitational lensing, where we can sort of detect invisible objects by looking at how the light um, bends around these massive objects. And so if you look at a star, and there's a star behind it, you'll see the light kind of like making a halo around it. So not only can we see the star, but we can also kind of tell how massive it is by how the stuff is bending around it. Like light, as it travels through the universe, it takes all these bendy routes because it's affected by whatever massive stuff it happens to go by, because massive objects affect the trajectory of light due to their gravity. And when we make these maps of the universe, we see that there's a ton of stuff in the universe that is just absolutely invisible to us. We know it's there because we see the light bending around it, and so we know there's some massive stuff there. But we know that it doesn't interact with light. And what that means is that we cannot, there could, if there was a Sahil that was made of dark stuff, and that dark stuff couldn't interact with light at all, we could literally, we could be just as dense as me, and we could just walk through each other easily. People might have heard from high school, whatever people say is an atom is we're 99.9% empty space, right? The particles actually make up our bodies, are taking up a very very small, we're basically transparent. And if it wasn't for the fact that our particles interact with light, we would just pass through each other. And we have examples of this. There's a particle called the neutrino, which doesn't interact with light. And millions of them are passing through our body every fraction of a second. And we don't notice it because they don't interact with light. And so we know that there's this big part of the universe out there that's sort of pulling and pushing on light rays and kind of clustering and helping galaxies form their structure. We see this out there, but we don't know what it is. And it's one of the biggest outstanding problems in physics right now.
Yeah.
Mm-hmm. What
what
about dark energy, real quick? Oh,
yeah,
go ahead.
yeah.
Sorry, Tim.
I guess I'll add that. Yeah. So physicists are able to kind of balance the energy budget of the universe by looking at the data and how to fit it, right? So they find that in terms of the energy of the universe, the stuff that we see, the stuff that we're made of, that stars are made of, that planets are made of, is only 5%, I think, of the total energy budget. In the dark matter, there's 5 times as much dark matter than ordinary matter. And of course, because of the accelerated expansion of the universe, and the only way to account for that is to have almost this new class of stuff, that causes the universe to expand. And that part is called dark energy. And for the longest time, we pretty much have no clue what dark energy is. So it's kind of like a placeholder. But there's also recently, previous episode, there's some evidence to suggest that even dark energy itself might be some type of stuff, sort of like particles, and maybe it itself can do more than just push the universe and cause it to expand. And so and dark energy, I think it's the remaining 70%, I think, in terms of energy. Hopefully.
5 plus 25 plus 70, right? Is that at 200?
Something like that. The numbers might give or take. Yeah. So if you think about it, we are just 5%, and there's the bottom 95% of the energy. We truly don't have much of a clue, right? And this is what we're talking about. Because we don't know much about these stuff. There's actually the plausibilities are wild. They could actually do a lot more than we think.
So I guess that kind of begs the question, why are we even going down this train? Why can't we just keep it simple and say, oh, there's this 20 plus 75 or whatever, this 90+% of the universe that's just, what if it's just kind of like an ether, just sort of, is just, just kind of around, sprinkled around uniformly, and it just is there. And then what we see is all there is to it in the sense of what we've observed. Why is this new sort of structure coming into place? It kind of feels like it has a multiverse sort of esque vibe of oh, this is an interpretation given in some sense. But I know it's probably not the case, but I want to point this out and ask for clarification on this.
I would say the way you just described it is very
Mhm.
close to the way like professional working physicists have been thinking about it for the
Mhm.
last 70 years.
Yeah.
Last 70 years, we've been assuming that, like you said, it's just like basically just some non-interacting dust. It's just like some
Mhm.
super boring stuff. And um, I think that makes sense from the point of view of an investigator. I think people, physics majors might have heard like the I don't know what it's called, idiom like a spherical cow. Like when physicists try to like predict how a cow is going to move if you throw it, you can just approximate it as a sphere and you'll get the same answer. And it's a simplifying assumption. Um, and I guess because we don't know what dark matter is, we can observe its gravitational interactions and we can't observe anything beyond that. So it's kind of like this big mystery. The simplest thing to do is to assume that it's the simplest answer. And if that doesn't work, then we add a level of complexity to it. It would be ridiculous to just assume that it's like off the bat that it's some super complex thing and it behaves like this and this and this and this and this. Like, right, you'd be like disproving, you'd have like a list of like a billion theories to disprove. So it's easiest just to like make the most basic assumptions possible and assume that it's just like some dust stuff. And the thing about that though is that we've been working under that assumption for the last 50 to 70 years and built experiments to detect this kind of like really simple, dumb version of what, the dark sector could be or dark matter could be. And they've all come up with nothing. And so now I think we have to consider the possibility that maybe it's actually something a little bit more complicated.
Hmm. What like I guess what does this extra complexity allow you to do? Like typically you, as you're mentioning, you just wouldn't introduce complexity willy-nilly. So what like I guess what problems out there would extra structure that you're introducing here with dark matter and dark energy allow you to like I guess find a resolution for potential resolution for? Maybe Tim, I'll
I
put
just
this
I just
question
need
to
to
you.
give a really
Yeah.
stupid answer to that quickly. Like
Yeah.
the practical answer is what it could do for you is it could make it so that it would have evaded detection, right? Like we looked for
Hmm.
the simplest thing and we didn't find it, but we know
Mhm.
it's there. So how do you explain that? Okay, well, how could it be there, but we wouldn't have seen it? Like that's how a physicist would approach it. But if you think about
Mhm.
it, that's like very anthrocentric. It's very human centric, right? Like nature doesn't care
Mhm.
what's easy for humans and what's not. Like if we
Mhm.
look at our own sector, we see it's very complicated, and there's things that appear here that would have been impossible
Mhm.
to guess. Like if you weren't familiar with this world, and so I think it's just like an irreducible possibility that
Mhm.
there could something like that could be going on there.
Yeah, but I would say that of course, physicists are very hesitant to introduce unnecessary ideas just for the sake of it, right? Like this is just hammer into our head. Like we don't do that in physics, right? I mean
No,
that's
but for good
that's
reason too. It's like, well,
yeah.
it's like why this and not that? Like, are you just making up random stuff now? Like,
Right,
Mhm.
right, right. Yeah, but I would say like over the years, increasingly we have experimental evidence that hey, something might be going on. Like a prime example is this dark energy changing bit, right? Like in our previous two episode, for the longest time, people thought dark energy is just a cosmological constant, and please do check out our previous episode to find a better explanation for this. But recently, hey, people realized that hey, dark energy itself might be changing. And because of that, people have to look for more complicated models. And these models, called quintessence model, we explored previous episodes. This is the very definition of the dark sector. Dark sector just means there's no agreed upon definition, but it usually means stuff that's dark, but it does something more than you think. If more than the simplest version, right? So like
and
quintessence, I
dark,
would
dark meaning that it doesn't talk to photons. That's
right,
it.
basically, yeah.
Yeah.
Yeah. So quintessence, for example, is a type of a dark sector model, probably, if you expand that a little bit. And also in cosmology, we in astrophysics, we have a few, you know, puzzles actually, that could deserve some attention, and some of these are quite thorny. For example, at the center of every galaxy, we have a supermassive black holes. physicists don't really have an idea how these form. They're kind of so large that it's a bit unusual, right? So people have studied what if dark sector has very strong self interactions, and by what do I mean by self interaction? Basically, if dark matter stuff, or at least a part of it, behaves like us, right? Like if I touch my two hand, the fact that they repel each other, they are strongly self-interacting. Like
We
that's
are strongly self-interacting.
exactly right. So basically, people have explored that if dark matter or some part of dark matter have strong self-interaction, it could actually make a supermassive black hole much more readily. And there are also a few little hints here and there, like the way the galaxies rotate, follow some particular patterns. But I won't go into too much details. But there are just a few hints left and right here that indicate that, hey, look, maybe if we introduce more complexity, we could solve some of these things. Yeah. So this is not like a totally crazy idea.
I see. I see. So what you're saying is that there's certain unsolved problems out there in cosmology that if you introduce this extra complexity, it could solve the problem. On the thought of black holes, like I'm curious, like we can't really know what they're made up of, right? Like it's not like black holes, it's definitely confirmed that black holes are made up of dark matter, for instance. Is that fair to say, or like
Yeah, yeah, you can't really say black hole is made of anything because black hole inherently involves quantum gravity, and from
Mhm.
the eyes of quantum gravity, all matter and energy in some sense are equal. So as long as you jam enough matter in a small enough space, they're all equal. They're
Mhm.
all created equal. I guess black hole is sort of like the least discriminatory thing, right? So that, in some sense, like dark energy could have created dark black hole if the conditions are right. Somehow they're able to do that, but probably not. Uh, yeah. So that's why like it's a candidate, but of course, it's not the only plausibility, right? But that's something people should explore.
I just wanted to chime in about like the question about what a black hole is made of. Um, right. So this is an interesting question where, like, depending on who you talk to, you'll get two different answers. If you talk to a general relativist, someone who thinks Einstein's the god of all time, then they'll tell you that black holes are more like particles. They only have three properties: mass, charge, and spin. So they're really just like they're all made of the same stuff. You can't tell one from another. Now we know if you talk to someone sophisticated with sophisticated understanding of quantum theory, we know that black holes are actually it's kind of true. They're very, very approximately have only these three properties, but if you look very, very closely, there's some indescribable complexity encoded on the surface. And it's almost like the most complicated Joule type thing you can possibly imagine. So the question of whether dark matter could be inside of people have asked whether or not black holes could be dark matter, like the primordial black holes left over from the
Mhm.
Big Bang. There are some theories like that. So it can go both ways, I guess. I guess I don't know, the latter question makes more sense to me, I guess. Hmm. I don't know. I'll have to think about that one.
I I guess this kind of makes me go on the train of thought of like um how complex can these structures get? Like are you talking like atom level complexity, like you talking like life level complexity, or like super intelligence level complex? I don't know, I'm just throwing out terms
Yeah.
out there, but like how complex can this get is my question.
So let me try to answer that first. So
Mhm.
experimentally, some of the hints that we have of these structures, of course, very large because telescope cannot resolve small things, right? So in some sense, the supermassive black hole is a type of structure, right? It's a very sophisticated structure that we don't know
Mhm.
exactly how to explain it with the ordinary model. So there are these structures, and there are some evidence that at the galactic level that shows that there are these dwarf galaxies that are somewhat unexpected. So perhaps a dark sector could help create those. Um, So experimentally, the evidence is at the kind of like the galactic level. We might be seeing a little more structure than anticipated. So if you would like to solve these problems, the dark sector should be able to create these structure. But if you take a step further, well, how is it possible that some dark stuff is able to create structures like a galaxy? Then if you zoom in, it must be able to create smaller structure first so that these form slightly larger structure and then larger structure. But once you open the Pandora's box, because the way we know how large structure like galaxies can form is through these like you make atom bond together, they form like small structures get bigger and bigger and bigger, eventually form galaxies, right? So there's a level of like a staircase complexity, right? So if we apply that kind of logic, the tendency is that in order for dark sector to create these large structure, it also has to create small structure. And now we're going into the realm like, hey, look, perhaps the dark sector stuff could make things like dark atoms, dark molecules, dark planets, dark stars. The possibility now becomes crazy, almost.
So you're saying there could basically be like an entire copy of this universe just all dark or something like that. Is that fair, or is that a little bit much?
Unlikely to be an exact copy. So I think the question Tim answered is was like, based on our observations, if you were to say that maybe this dark stuff is like complicated in some way, like like what kind of evidence do we have for the way in which it can be complicated? And it's kind of like a bottom-up approach, but I think we have to think. I feel like it's like that story of the five blind guys who touch an elephant, and one touches like the tail and thinks it's a snake, and the other touches the leg and thinks it's a tree trunk. Like we are blind to this stuff. Like what we can observe about it is like it's evading all of our senses except for one, which we can see in a very coarse-grained way. And like so when you ask the question of how complicated can it be, I feel like the limitations of our imagination is the only thing that is the possibility. There's literally like if you talk to certain conservative physicists, they'll say like, oh, it can't be self-interacting to this degree, otherwise we would have seen it collapse into a disk, and we actually see it more like spherically shaped. And yeah, all that stuff is true, but I feel like it just smells like hubris to me to think that just based on these feeble observations you can kind of like eliminate all these possibilities. Because if someone tried to guess what our light side of the universe, the 5% of the universe that does interact with photons, is incredibly complicated. And all kinds of phenomena arise that would have been very hard to predict if you couldn't see light. So the idea that we can guess the complexity of what's going on in the dark sector seems very very arrogant to me.
But I mean, people have written papers, and I can give some examples. And of course, the limit really is our imagination, right? Because we only have references to the stuff we see. But when we talk about the stuff we don't see, who knows, there could be entirely new hosts of phenomenon that we can't even imagine quite yet. But when people borrow experiences from stuff that we see, people have worked out some example. For example, some people have studied superconductivity. Like when electron bond to form Cooper pairs in the middle. And people have thought about, what if dark matter is something like that? So we might be kind of in an ocean of some sort of liquid, super cold, like quantum liquid, that we're swimming in it, and dark matter is sort of this coherent gel. Gel is probably not the best ways to put it, but it could be like an ocean of dark matter stuff, and then these dark matter stuff could undulate and form sound waves and whatnot, and influence the way galaxies behave. That's one possibility. The other possibility is like what Sahil you say. People have borrowed experiences from our world. Maybe dark matter could form things like dark atoms, dark molecules, right? Like layers and layers, and then eventually form dark planets and dark stars, right? And then there are other possibility, like somewhere in the middle. It could be exotic stuff. Like I myself have written papers on something called like dark nuggets. It's almost like you imagine if dark matter can undergo fusion, but instead of having periodic table, imagine a periodic table that's infinite. Then you can have dark matter with one dark nucleon, with two dark nucleon, and maybe 1,000 nucleon. So you can have these crazy, sort of never seen before structure. So I mean, the possibility is really just endless. But like it's like a theoretical physicist playground, basically.
As
Yeah, I
you
guess
put all your hopes and dreams in there.
I want to double click on like the compelling evidence, or at least what evidence you find compelling for there to be more structures. So far I've heard like, oh, it might be able to answer these questions, and there's just a lot of stuff of it out there, like more than like us, like 20x more, something order of magnitude wise greater. Like what other, like, I'm coming in very skeptical here. Like what other evidence can you point to that gives rise to more structure? Like, I mean, what if it just has different concentrations and you like go further out, kind of like a dilute gas? Like, just why do we even need this structure? And like, what if there's some simpler explanation of like supermassive black holes? Maybe like, the conditions of the Big Bang where like there was a bunch of matter clumped together and then the rest kind of spread apart. It's not like exactly homogeneous, but I'm trying to come in very skeptically here. So
Wait, hold on.
I'm playing
Okay,
the
so
devil's advocate. Yeah.
Tim knows more about this than I do. So before he gives a more detailed answer, I just want to say like I just want to pose a question. Like,
Yeah.
give me an example when the universe made something boring.
I mean, boring is in the eyes of the beholder. It's just kind of
Dust is boring. I think everyone would agree that dust is boring.
I don't know. I think dust is exciting. I mean, Stardust gave rise to us. Like it's pretty damn exciting. I
I
I,
mean,
I
that's
wouldn't I
different.
wouldn't say so.
That's a special kind of dust. But I mean, dust. Yeah.
Well, I would argue that like if you have an alien, I don't know, like some kind of being that's not made of the stuff we see, and they try to
Uh-huh.
measure the universe, the first thing they will see is dust, and they would think that hydrogen atom is the matter of light. That would be the only thing they
Hmm.
see. Until they are able to probe deeper, they would not realize that hey, hydrogen is actually made up of electrons and a proton. And guess what? Protons actually also can bond with a neutron because those are so rare,
Mm.
right, in their eyes. But to go back to your question, and this is something that the field struggle with, right? Like you can always ask the question,
Hmm.
that where's the evidence? The truth is, yeah,
Hmm.
there is not much evidence. I mean, that is the honest truth because this stuff is dark. You really just can't measure it very well. Like the best thing you can do is to measure the statistical average of these things. The best thing you can do is say,
Hmm.
hey, give me stuff at the galactic scale. We can see its overall behavior. And sure, you can have a simple thing and a complex thing, and there could be 1,000 possible things, all gives the same averages. But the details would vary. And this is always going to be a problem. You're almost never gonna have detailed evidence for this. And people do struggle, like is this science on some level? But I would say at least on a scientific footing, this is somewhat better than the multiverse, right? Like this stuff is out there. Maybe one day eventually we will dig into the details.
Yeah, there's at least in principle a possibility.
Right. But I think the counter argument is that our field has been so over indexed on the super
Hmm.
simplified picture that I think many people would argue that it's sort of not representative on the reality we observe anymore. So I would say it's not. I mean, it's not the best argument, but I don't know. Like that's the reasoning logic behind it.
Okay, if you insist on being data driven, then everything you said I agree with. but like, what does a theorist do? Like, in like a romantic sense, right? Like, what a theoretical physicist does is like we think that we have some sense for what Mother Nature likes to do and what she doesn't like to do, right? And we try to use that to try to imagine like what might or might not be a likely scenario in terms of
Hmm.
like how surprised we would be, how different it is from the things we've seen. So, and I think having us having worked in the field for like better part of like over a decade, like we like to think that we do have some kind of understanding of what Mother Nature's preferences are in terms of what's allowed to happen, what's not allowed to happen. And we've been spanked because of this hubris time and time before again. But even so, it's not like it's like we're totally wrong. It expands our understanding of these preferences. And so yeah, it could be something completely unexpected, completely different from anything we've seen before, but that's actually pretty rare when that happens. I actually can't think of a single time when it's actually been like that.
Hmm. So the arguments I'm hearing are more, I guess, like beyond just some hints, like tiny
Like,
hints experimentally.
yeah.
It's more like theoretical that this is like, I don't know, kind of like because we know so little about the universe,
Yeah.
there could
Yes,
be a
that's the
lot
key
more
point.
options out there that are
Yeah,
far more
like
interesting than we
the
can
more
imagine.
blind we are, the more fantastical the possibilities could be, right?
Yeah, I mean, I see this even in other fields, like genomics is one where I think it's like only 5% or something of the DNA like actually produces protein, and the rest is just considered quote unquote junk, but no one knows like what that's actually for. I think something like that.
Yeah,
I
but
don't know the exact
but,
numbers.
but people find that like, oh, these snippets are like activated during certain, so like it's not joy, it's kind of like the like we have examples of where those junk portions are actually useful for some kind of like memory, like mammalian diving reflex, for example, like you can actually
Hmm.
part of it. Um, but yeah, I'm sure we have a lot more to learn about that as we
Yeah.
do about
Al-
this dark sector as well.
Also, I mean, I mean, to kind of lean on this theme a little bit more, reminds me a bit of the dark web. There's like more of it than the actual web that we see.
Yeah. Yeah.
So I just I just feel like there's this theme like of we just know a very tiny slice of like what the thing actually is, and the rest just like is completely dark in that sense. So yeah, okay. I guess maybe I can see that point of view. So I guess where does this like leave us in terms of particle physics and whatnot? Like also I'm curious about like if this impacts, kind of asking a more sci-fi type of question, like is the, I guess, like do they follow, I guess, like do they have a similar notion of time, or is it different? Like
Wait, hold on. Wait.
yeah,
Let's just bring out the elephant in the room because you already said
okay.
do they now. Okay, so the elephant in the room is is the dark matter, are aliens hiding in the dark matter? I feel like that's the elephant in the room, right? Like, is it possible that this dark sector is complicated enough to create complex networks of information that could be interpreted as intelligence in some way?
Yeah, yeah.
You already dropped it. You said like, do they? So once you said that, I was like, okay, cat's out
I
of the
can
bag. Let's bring it
confirm, I can confirm nor deny it.
on.
But
The record will show.
Yeah, but let me add that I think the implications, just to answer the first questions, right? Like the implication for science, if something like the dark sector exists, is that if it does, it's that then it's so hard to test any of these hypotheses because the reason they're dark, like because they are dark, they don't interact with us very much. Like how do you run an experiment on something that we cannot control? You
Unless
know?
they make contact first.
I'm not gonna go into that yet, right? But then we're just gonna left with this possibility that there could be structures, complicated structures. I don't know at what scale. Could be planetary, could be star-like, could be human scale. could be extragalactic. Like there could be structures there, and we should look for them. And there are experiments actively doing that. Although they're never going to be good enough to test some of these crazy hypotheses. So that's one thing. So probably within our lifetime and within thousands of years, this will always be in some sort of fantasy imaginary land. But then some of these plausibility will always remain. Yeah. I don't know. I guess we can move on to the second question.
Could they form jellyfish-like structure?
I kind of want to point the spotlight of this question at Tim about aliens, because Tim, you rarely talk about aliens.
Love talking about what are we talking about?
Yeah, I want to hear from Tim first about dark aliens. What's going on with that?
Well, the thing is, if you embrace the plausibility that dark aliens exist, let's say there's some dark intelligence floating around the cosmos, because they are dark, chances are we won't see them very much. Yeah, they'll just pass right through us. But that's not to say that, just because things are dark doesn't mean that they're 100% dark. There could be, in the dark sector lingo, there usually is some sort of portal. And I don't mean a physical portal. I mean a theoretical portal where the dark stuff and the light stuff...
You could make it a physical portal. Like you could
Sure,
I think what you're talking about is absolutely, in principle, could be a physical portal.
Right, but that idea is a theoretical one. Yeah, but in order for this stuff to be interesting, there needs to be some way to some interaction between them. Of course, it's also perfectly fine to have a model where dark stuff and light stuff literally have no way to communicate with one another. That's plausible. If that were the case, sadly, we will almost never find dark beings, right? Dark star, dark planets, dark beings.
They're right next to us, and we'll never be able to talk to them.
And they will also never see us. Maybe there's Dark Tim right here. Although I don't know if they'll be called Tim. Like, language might be totally different. But I don't know. Is this science? You can never talk to each other, but it's there. But in principle, gravity maybe. Like I don't even know.
That's why Interstellar was so brilliant to hide these beings. Yeah, this is essentially the plot of Interstellar, but yeah, and Kip Thorne smartly hid them in gravity.
Right, like if they are somehow able to excite enhance gravitational interaction in some ways,
or just master the ability to manipulate gravitons. Yeah,
I'm not sure if that's even possible, but if that was possible, yeah, that may be the only way you see these things. It will be like gravitational anomalies, right? Just like what the hell? The book fell off the bookshelf.
It's the most likeliest.
I'm just having this visualization of these like really jacked dark beings that just move and then cause these gravitational waves. We can interact with them out. The gravitational waves interact via light. I don't know. That image is coming to mind.
Well, maybe at least we can go through some of the physics of dark sector. Okay, of course, there's the gravitational portal, but within the literature, there are usually, I think, 3 types of portal beyond the gravitational one. One is the the photon portal, right? Dark light and ordinary light. There could be a dark version of light, and there could be ordinary light. They can perhaps really rarely convert to one another. That's the light. That's the photon portal, right? So that's one possibility. So even though like we can't touch them, but if we try really really hard, like occasionally maybe you do touch them, right?
It's like a big hill you have to go over to access them. So it's
right.
There's a portal, but like it's like a really hard wall. You gotta break through it.
What do you mean try really hard? Like I have to punch through it like with a lot of energy, or like what do you mean by really hard?
You have to punch a lot of times.
A very high energy density.
And also many times. Yeah. So
it's like let's say that there's like our light, like the light that we interact and see with, and there's some like dark shadow, like invisible light. But like let's say that in order for them to talk to each other, they can only talk to each other through a friend. and that friend is very, very, very large. So in order to summon that friend, you need to condense a lot of energy here to summon this very, 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 very large friend, and then you can kind of go over that. That's kind of the analogy.
Yeah. Yeah, so people, I would say that people literally have done experiments like at Stanford, SLAC, at some of the accelerator.
Every particle accelerator is doing this experiment.
Yeah, so basically, in a particle accelerator, when you have a beam coming in trying to collide, at some point the beam need to be discarded. So they literally just dump it in like a mountain of concrete, like literal mountains. They just shoot the beam into the mountain. The idea that if you shoot so many times, maybe once in a while, like really rarely, a proton can punch into the dark force and then hit something behind it. Just like, because light cannot go through the mountain, just literally. So they tried that a trillion, I don't even know how many trillion times. Keep punching through the mountain to see if it can punch into the dark sector. Yeah. So there are experiments like that.
We have literally been just waiting, looking for that for about 45 years right now.
Is it 45 years?
I mean, I'd say since LEP, that's probably the first time when missing energy searches became like a big thing, and
maybe.
I would say about 45 years.
But it has become more fashionable in recent years, maybe.
Yeah, I'm sure it wasn't that popular in the 80s, but
yeah.
We didn't have the technology to really look for them back then, but people tried. I'm sure people tried.
So is this kind of a missing energy type of problem? Like, let's say this experiment actually worked. Like, what would I be looking for? Like, I'm hitting.
Normally, when you collide stuff, you see stuff going out, and what you see going out is exactly equal to the energy going in. If you saw some stuff just disappear, that would be a sign of what we're talking about. And actually, Tim and I were both in our very younger years, like heavily involved in this kind of search, because it's like kind of the easy to look for. So that's what they hired us to do.
Yeah. How is this different to like neutrinos, for instance? Because neutrinos you can't see on a bubble chart because they don't have light.
So we always see a little bit of this missing stuff because we know we're always producing some neutrinos. So if you saw like extra missing stuff on top of what you'd expect from neutrinos, then that would be a sign.
Yeah.
But I guess then if you I see, then it would have to be something different than neutrinos.
Yeah.
But then how do you know they aren't
taking into account neutrinos? Yeah.
Yeah. How do you know they aren't like a fourth generation of neutrinos or something like in the neutrino family?
We think that they could be that fourth generation neutrinos. This was a very trendy candidate for dark stuff.
I see.
That'll be a discovery. I don't think physicists will complain if they try to find dark stuff and they found neutrino. And also a fourth neutrino is also kind of part of the dark sector.
Celebrate.
Yeah.
I wouldn't. That sounds boring.
So indeed. Okay, so the photon portal is just one of the portals. And I'm glad that's how you're bringing this up. One of the portals is a neutrino portal, right? So neutrinos don't talk to us very much, but there was speculation that maybe neutrinos talk to the dark stuff because that's where they can hide, right? So if that were the case, maybe I don't know, a radioactive decay make a neutrino, and then the neutrino could easily punch through to the dark sector and do some stuff, but it's hard to detect.
That's a particularly interesting idea because neutrinos in a lot of ways are like they're only like half of a particle, and so there's kind of a question of like where's the other half, and it's like it's a nice idea that maybe the other half is in the dark part.
Right.
Yeah. I guess I'm curious, like what I'm just thinking. I had a question now it's completely escaped me. Shoot. Yeah, no, it's not coming back.
Maybe it went to the dark sector.
I remember. If we like could control gravity waves, let's say we advanced far enough to be able to produce gravitational waves like at our whim, would we then be able to really probe like what these things are?
If we could do that, then we could do anything. Yeah. If you could do that, then you have access to the Planck scale and you are God.
Because is there anything like gravitons can't see? Like, I'm just curious,
No.
is gravity
No.
truly
So
king?
we
Yeah.
think that there's nothing gravitons can see, and so that's why I say like we have a very feeble ability to detect this dark stuff. We only detect them through like second, third, fourth order interaction with gravitons, which is like this bending of
Mm,
light. Yeah.
mm,
Um,
mm,
and it like Tim mentioned, if it's true that gravity is the only mediator, the only friend that can talk our language and their language, then we'll never know, because we'll
mm,
never be able to, as you said, like manipulate gravity to that extent.
Well,
If there's
hypothetically,
another
right?
friend other than gravity, then there's a chance. Yeah.
Yeah, I guess hypothetically, if you could manipulate graviton, let's say, for whatever reason,
mm,
yeah, then yeah, you can see everything because by definition, for an object to exist, it has to have energy, and energy couples to graviton. So you can always make a energetic enough graviton to make anything you want, basically. So it's the
mm.
universal creator almost. So,
Gravity's the
I
only
see.
universal thing.
probably not, but who knows?
Uh,
I mean, so we can't say. I mean, it's not even. Is it not even meaningful to talk about things that like don't interact with gravity? Because effectively they would have zero energy. Is that like? I know we're kind of
Yeah,
going a little bit off tangent, but
yeah, that
I'm
might
just
also not
curious.
exist. I think if something doesn't interact with graviton, first of all, Einstein's theory will break. Einstein will be
Uh-huh.
wrong.
It means Einstein's theory is wrong. It means that string theory is wrong. It means that everything is, yeah. It means that we don't.
Ah.
If there's something that doesn't interact with gravity, I'm not going to say that that's impossible. But if you tell me that's true, I will. I'll probably just end it there. I'll probably just.
Then gravity is not gravity, right? Then it's
I
just
don't see any
yeah.
purpose in living beyond that. Like,
Then
you would be taking away the only thing that I've ever been certain in my life.
well, I think it's safe to say gravity is king, as Tim has mentioned many times in many
There's
different
just so
episodes.
many different reasons to believe that's true from so many different things, and so like, if you're it like if there's one thing that you can, if it's, for me to feel comfortable, there are certain things that I need to view as like unlikely to change. I need some
Mhm.
constancy in my life. And I need
Yeah.
to like latch onto these things that I believe will not be disproved for a while. And that's the very top of the list.
Yeah, that makes sense. So yeah, so we're nearing the end of this episode. So I want to, in our tradition, give you guys a chance to leave the audience with any words of wisdoms that dark sectors have taught you.
Yes,
let me just
mine's gonna
sorry.
be quick. So maybe first, the
Sorry.
aliens are in the dark sector.
That's an opinion, right?
No, that's a fact. I'm not. I'm gonna. I'm placing this bet here to anyone who wants to bet against me and accumulate whatever odds are fixed at this point. I don't know. Yeah, I'm putting $100 here now, and however unlikely you think it is from now to the rest of the time, you can put your bet. Yeah,
I
aliens.
I'll say given caveat, if aliens are real, and let's say they are very advanced, and that dark sector exists, I would be very surprised if they don't take advantage of the fact of the physics in the dark sector.
Hmm.
They probably know much more about it, and somehow, well, also assuming dark sector
Mm,
actually does talk to us in some maybe minimal way, but still you can manipulate them, and for sure, and I bet you there's something to be gained peering into the dark sector.
mm,
It would be
mm,
insane, I think, to have dark sector in the universe and just you couldn't do anything. You couldn't
mm.
play with it. That would be crazy. That would just be weird. But
Nature doesn't waste resources like that. Typically, she doesn't like to waste resources.
oh,
Yeah. Was that all you wanted to say, Tim, or you wanted to add something
oh yeah,
else,
I do
or?
want to add one thing. So we were talking about the different ways dark sector can communicate with us, and just want to wrap that discussion up. So the first thing is
Sure.
gravity. They definitely talk to us through gravity, but it's really hard to detect. And the first possibility was through what we call the light portal, the photon
Yeah,
portal. Yeah, that has gained popularity in recent years. And the
it
second
makes sense.
portal yeah, the second portal is a neutrino portal because we see neutrinos and they are very dark already. So it seems to make sense that
And
maybe
they're only
they are.
half a particle.
Right. Yeah. That's probably the closest thing to the dark sector that we see. Right. And the last one that we didn't discuss very much is the Higgs portal. It could literally punch through the Higgs, and in some sense, the Higgs is kind of an oddball in particle physics. I guess it's not as dark, but because it's so strange,
Nice way to put it.
It's a good place to hide stuff, basically. So that's most of the possibility. I'm sure there are other more crazier, exotic possibility, but these are the main possibilities.
Typically, the truth is something crazier than we could have imagined, right?
Probably.
That's kind of a trend. So
yeah,
I wouldn't be surprised.
Yeah. Well, Mikey, you seems like you're seeing aliens from the dark sector.
Absolutely.
I guess, Tim, do you want to leave the audience with any parting thoughts about aliens or any other things?
We would have seen television signals. We would have seen stupid aliens, like from the beginning of their like stupid alien culture, right? Like we would have seen them, and if they were light, we would have seen them. It must be somewhere else.
I don't think I'll go as far as aliens, but personally, I have written, in the later part of my career, I have quite a few papers on things like dark stars, I talk about the dark nuggets idea that I worked on. So certainly I buy into that narrative a little bit. Personally, am I 100% certain? Of course not. Never 100% certain about anything.
Not crazy.
But it is quite tantalizing if you just look at look at the stuff in our world. How much of it is just like, why is it there? Like, what the heck? Yeah, we couldn't even answer that question. So it would be insane to think that, all there is for dark matter and dark energy is that it creates the effects that we observe. Like that would be crazy if dark matter
here for us.
Yeah, like dark matter is only here because galaxy need to cluster. That, like, what? That'd be crazy, right? Like, it's almost like this third layer of a human centrism, like just going away, basically, right? If you take that lens, I think they are dragons in this, like, not literal dragons, but like there's something crazy.
That's a good point. It's very Copernican to think that dark matter is boring.
Yeah, so I think this sort of depends on your philosophy, but I think the new generation is definitely more toward the opinion that, like, hey, look, stuff happens, man. Like, it's probably not what we think. We need to be humble and kind of accept that, and stretch your imaginations sometimes.
Yeah. Well, on that note, I want to thank everybody for joining us. We'll see you all next week.
Yeah. See you. Thank you. Bye-bye.
Bye.
Right. Hey guys, I actually know now that next Sunday, like my parents are leaving, so I